Hi everybody, Derek here from Automotive Oscilloscope Diagnostics. So guys, today I would like to show you how to carry out a relative engine compression test using an oscilloscope. My choice of oscilloscopes for any diagnostic work is the Picoscope 4425. It's a 4-channel oscilloscope. I'll be using this in conjunction with the Pico diagnostic software that's loaded up onto my PC. We are filming from my man cave today, so this is my car we'll be doing the test on. It's a Land Cruiser 150 series Prado, fitted with a 2.8 litre turbo diesel engine. So guys, from a connection point of view, very easy to set up. I have a standard set of leads which will connect to the vehicle starting battery, positive and negative terminal. The other end of the lead, which is the BNC connector, will connect to channel 1 on the oscilloscope. And I also have a USB cable that will connect the oscilloscope to the PC. Now, other things to remember: the vehicle's starting battery needs to be fully charged to obtain accurate results. And I also need to disable fuel delivery to the engine to stop the engine from starting during the compression test. Now, there is a number of ways of doing that. For me, it's pretty simple. I have a diagnostic scan tool which I'll be able to use to connect to the car to then prevent fuel delivery during the compression test. Okay guys, I have completed the setup. I have opened up the diagnostic software on my PC. I have turned off fuel injection to the engine on my scan tool. I will now press the start button on the diagnostic software and I will proceed to crank the engine. Okay, here we go. So there you have it guys, the Pico diagnostics software has identified that the relative compression on this engine is good, 98 to 100%. It also shows you the cranking speed of 228 RPM. So how do we interpret these results? Well, we need to keep in mind that this is a relative compression test. It does not measure compression pressures, but simply compares one cylinder to the next by tracking the battery voltage changes during cranking. So guys, this is what a relative compression test looks like on a good engine. Now, I'd like to show you what a relative compression test looks like on an engine that has bad compression on one cylinder. However, this is a diesel engine. There's just no practical way of simulating a bad compression on one cylinder on this engine. But I do have another vehicle in this garage. It is a motorcycle. It is a Kawasaki ZZR 600. It is a 4-cylinder 4-stroke engine. It is very easy for me to simulate a bad compression on one cylinder on that engine, and I'd like to do that for you now. So guys, this is it. This is my ZZR 600. I am currently doing a major service on this motorbike. Now, there is nothing wrong with this engine, right? So to simulate a bad compression, I have removed the spark plug from cylinder number 3, and I'd like to show you what a relative compression test will look like on an engine that has a bad compression on one cylinder. So guys, I have now connected the Picoscope. I have disabled the engine from starting, and I am now ready to crank the engine and carry out the relative compression test. So guys, with the relative compression test, the software designates the cylinders in an alphabetical order. As you can see from this test result, the software has identified that the percentage value for cylinder D is very low. Now, the software cannot determine whether it is cylinder 1, 2, 3 or 4. So guys, I hope you have enjoyed episode 1 of relative compression testing. Be on the lookout for episode 2, where I will show you how to use an amp clamp to carry out a relative compression test. Plus, I will use a trigger signal to show you how to identify the malfunctioning cylinder. If you have enjoyed this episode, smash like or hit me up in the comment section. My name is Darek Starostecki. Thanks for watching.